Hello everyone, welcome to Cloud Pedagogy. Today we are going to discuss fundamentals of cloud computing. Before going ahead, first we will discuss what is cloud and why do we need cloud and why do I care about it. So who are the cloud providers that are available for us right now? Types of cloud computing, and we'll also learn what is server and serverless services we have. So let's go ahead. What is cloud? Cloud can be a little daunting if you haven't done it before, especially if you're a beginner. It's a new paradigm. It's a different way of doing things, so it is really easy to get started. I come from an Amazon background, so obviously I would recommend Amazon course in my coming videos, but from my personal point of view, I think Amazon's the easiest thing to start learning. The term cloud really has its roots back in the start of the internet. In its simplest form, it just means storing data and accessing computers over the internet. The on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon services, Google Cloud Provider, Azure, etc. So we learned about what is cloud. Next we'll go ahead. Where did cloud computing comes from? We are going to discuss the origins of cloud computing and where it came from. Now, cloud computing comes across the term virtualization, where this is a process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. In 1963, the Defense Advanced Research Project Academy funded $2 million for a project which included developing a technology that allowed a computer to be used by two or more persons simultaneously. Now, this is the reason why cloud computing was invented. What they did was they used giant computers that acted as cloud, giving a maximum of 3 people to a computer at any time. In 1969, the Advanced Research Project Agency network has come into the picture and they built a concept called the Intergalactic Computer Network, where they would connect people and data from anywhere at any time. And as you see, where we are going here, this was the birth of the internet as well. So this is two pretty important things that created the cloud computing model. We had the Defense Advanced Research Project Agency that developed a technology where it allowed 2 or a maximum of 3 people using the computer simultaneously, and the concept of a computer network where you would connect people and data from anywhere, anytime in the world. In 1999, a company called Salesforce had been very successful using this cloud computing, and they delivered software over the internet to their customers to use their marketing CRP platform. So other companies were seeing that this was a big hit and they wanted to test this model out. In 2002, Amazon used this model to provide capacity for their own infrastructure and understanding where the market was going. In 2006, they have launched Amazon Web Services, or some of you know as AWS. And this was to provide companies an opportunity to use the model through their platform. I hope this gives you a great understanding about the origin of the cloud. Hello everyone, welcome back to Cloud Pedagogy. Today we are going to learn 2 new concepts, which is why do we need cloud and why do we care about it. First we'll see why do we use cloud. There are several reasons why we need cloud computing today. Here I'm not going into too deep, but came up with few points. I will tell you one great reason: speed to market. You wonder, what does that mean, right? Now let's look at an example. Let's look at a network that serves an application to its users that is on premises. I hope you know what is an on-premises network is. If not, let me explain. It's nothing but your office, and you might have noticed those server racks in the closet with fans going to keep them cool, right? And you may not have just paid any attention to them, but they are there. But those servers allows your company's applications to be deployed on them. So you can access your company's software internally or customers can access them externally. Now let's think about it. If a server went down, what would happen? Let's take a look. If one of your servers went down, this would disable the application that is on them, which means that the end user, either you or an external customer, cannot access any application that your company offers and eventually will be up in flames. I mean, well, not literally, but you get the point. But to replace the server, it can take weeks to get one shipped in. Then you have to attach it to your network, upload the software, install security patches, etc., 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 which means that it can take time that you don't have at all. Now let's look at the same scenario in the cloud. If you had a server offering the application to your external or internal customers or the internet and one of those servers went down, then you can literally have another server up within seconds with all your software and those software dependencies already installed and ready to go. This dramatically decreases the downtime and impact to the customer, either you or external customer. And this is just one example. This allows your company to push the product quickly to the end users without any downtime at all. Now there are other ways that we use cloud, and here are few of them. So we can use cloud for quick updates and integration of our product, services and software. This means that if we have an application running on a server, we can quickly update our application to do whatever we need it to do within minutes. We have high availability and fault tolerance. Now what this does is ensures, just as the scenario we just talked about, that this allows you to stay available to your end users without any downtime. And we could use for unlimited storage, and you can use the cloud to store any files no matter the size for as long as you need. And now we currently use some companies like Dropbox, for instance, or even iCloud that you know that uses cloud services like AWS. They act as the middleman. So that's about why we need cloud. But why do we need to care about the cloud in fact? So let me give you some quick reasons of why you should. Number one, as I have mentioned before, cloud is very easy for you to use and you do not need to have a technical background. For example, a person who do not have technical experience nor background, it's very easy to start with learnings. Number two, cloud saves you a lot of money. We have all heard it before. Cloud computing can save you so much money. But how? By using the resources that are already managed for you. You can save a lot on costs that would have been allocated to major components like logistics, providing the network, staffing, etc. etc. Those things that you may have to come out of pocket with if you were trying to establish your own infrastructure design. But you also can have access to the cloud collaboration tools that you use every day now at a cheaper cost. Think of services like Zoom, Microsoft Teams, or even Google Meet, almost free of charge to collaborate with anyone across the globe. So, number three, cloud security. You can also call cloud computing security, which refers to the discipline and practice of protecting cloud computing environment, applications, data, and information as well. Cloud security entails securing cloud environments against unauthorized access or distributed denial of service attacks, hackers, malwares, and other risks. So, number four, cloud provides you with a guaranteed uptime of those services you use, meaning there is a service level agreement that a cloud service provider can guarantee you when you use their services. So, for example, that this service that you use will be available 99.99999% of the time. I know that's a lot of times, but that's how the availability they can guarantee it for you. Alright, you wanted to know why you should care about the cloud, and I just gave you a few great reasons. There are plenty more that we can dive into, but these are the most important points I can light on. And that's all for today's session. Hello Cloud Pedagogians, welcome back. We are going to discuss the types of cloud computing models as well as the types of cloud computing services. Let's start. There are four main types of cloud computing: private clouds, public clouds, hybrid clouds, and multi-clouds. There are also three main types of cloud computing services, which is called infrastructure as a service, platform as a service, and software as a service. Choosing a cloud type or cloud service is a unique decision. No two clouds are the same, even if they are the same type, and no two cloud services are used to solve the same problem. But by understanding the similarities, you can be more informed about how the caveats of each cloud computing type and cloud service might impact your business. First, we'll see what are cloud models. The cloud models define the deployment type of cloud resources. As I have already mentioned, we have four types of cloud computing, which is private, public, hybrid, and multi-clouds. Let's start with a private cloud. A private cloud is in some ways the natural evolution from a corporate data center. It's a cloud basically delivering IT services over the internet that is used by a single entity. Private cloud provides much greater control for the company and its IT department. However, it also comes with greater cost and a fewer of the benefits of a public cloud deployment. Finally, a private cloud may be hosted from your on-site data center. It may also be hosted in a dedicated data center offsite, potentially even by a third party that has dedicated that data center to your company. Now we'll see private cloud key highlights. Organizations have complete control over resources and security because everything is located within the organization itself. Data is not collocated with other organizations' data. For example, in the public cloud, the same data center can be shared with multiple organizations. But in private cloud, you don't have that problem. Hardware must be purchased for startup and maintenance. That obviously takes you a lot of money in the private organization cloud. Organizations are responsible for hardware maintenance and updates. In simple terms, organization is responsible for everything. Next, public cloud. A public cloud is built, controlled, and maintained by a third-party cloud provider. With a public cloud, anyone that wants to purchase cloud services can access and use resources. The general public availability is a key difference between public and private clouds. These are the key highlights for the public cloud. No capital expenditures to scale up because everything is provided by the cloud provider. Applications can be quickly provisioned and deprovisioned. You can allocate the resources or deallocate the resources within minutes in the cloud. Next, organizations pay only for what they use. Obviously, in the public cloud, we can select what are the resources we want and we can just pay for what we use for. Organizations don't have complete control over resources and security because partially these are done by the cloud providers. The third one is hybrid cloud. A hybrid cloud is a computing environment that uses both public and private clouds in an interconnected environment. A hybrid cloud environment can be used to allow a private cloud to search for increased temporary demand by deploying public cloud resources. Hybrid cloud can be used to provide an extra layer of security. For example, users can flexibly use which services to keep in public cloud and which to deploy their private cloud infrastructure. Now we will see Hybrid cloud key points. It provides the most flexibility because you are taking not only your resources but also cloud provider services as well. Organization determine way to run their application. Organization will decide whether their applications has to be run in their private cloud or in the public cloud. Organizations control security, compliance or legal requirements. Usually in the hybrid cloud, organization will take control over the security, compliance and any other legal requirements. The last but least, multi-cloud. A fourth and increasingly likely scenario is a multi-cloud scenario. In a multi-cloud scenario, you use multiple public cloud providers. Maybe you use different features from different cloud providers. Or maybe you started your cloud journey with one provider and are in the process of migrating to a different provider. Regardless, in a multi-cloud environment, you deal with two or more public cloud providers and manage resources and security in both environments. So that's all cloud computing models. Before moving to cloud computing services, I would like to brainstorm a little more about the cloud. So I get this question all the time. Isn't the cloud just a storage? Well, when you think of cloud, you think a lot about the storage services that are out there like Dropbox, iCloud or even Google Drive. But cloud is so much more. Cloud offers you services for your computing needs, networking, database solutions and even what you now know cloud to be of, like file storage. Now let's name some of these collaboration tools that we use every day and we didn't know they were cloud. We are talking about tools like Microsoft 365, Google Workspace or formerly known as G Suite or even QuickBooks. These are the things that you use every day that some of you may not even know is a cloud collaboration tool. Now this is how cloud serves its purpose other than storage as well. Alright cloud pedagogians, today we discussed about the types of cloud computing models. We also tried to understand cloud computing is not just a storage. In the next video, we will discuss types of cloud computing services. Hello cloud pedagogians, welcome back. Today we are going to discuss the types of cloud computing services. Let's start. So before going to cloud service models, we'll discuss about shared responsibility model. You may have heard of the shared responsibility model, but you may not understand what it means or how it impacts cloud computing. Start with a traditional corporate data center. Okay. The company is responsible for maintaining the physical space, ensuring security, and maintaining or replacing the servers if anything happens. The IT department is responsible for maintaining all the infrastructure and software needed to keep the data center up and running. They are also likely to be responsible for keeping all systems patched and on the correct version. With the shared responsibility model, these responsibilities get shared between the cloud provider and the customers. Physical security, power, cooling and network connectivity are the responsibility of the cloud provider. The consumer isn't collocated with the data center, so it wouldn't make sense for the customer to have any of those responsibilities, isn't it? At the same time, the consumer is responsible for the data and information stored inside the cloud. You wouldn't want the cloud provider to be able to read your information, is it? So, the consumer is also responsible for access security, meaning you only access to those who need it. Then for some things, the responsibility depends on the situation. If you are using a cloud SQL database, for example, the cloud provider would be responsible for maintaining the actual database. However, you are responsible for the data that gets ingested into the database. If you deploy a virtual machine and installed an SQL database on it, then you would be responsible for data patches and updates as well as maintaining the data and information stored in the database. So with an on-premises data center, you are responsible for everything. With cloud computing, those responsibilities shift. The shared responsibility model is heavily tied into the cloud service types, or we call cloud service models. So, what are the cloud service models we have then? There are four cloud service models as I have already mentioned before. It is PaaS, SaaS, IaaS and FaaS. What is PaaS? Which is PaaS. I know some of you have seen the acronym before and have been wondering what it is. So let's break it down. First, what does PaaS stands for? PaaS stands for Platform as a Service. Now, Platform as a Service is a service that offers a complete dev and deployment environment for the cloud. Now, this can be offered through public, private, or even hybrid cloud models. Now, with PaaS models, you means like customer manage the application and data on a platform where the service provider manages the runtime, middleware, operating system, virtualization, servers, storage, and network. And this provides a model where you only have to worry about deploying your app to the end user while everything else is taken care of. Now here is some PaaS examples you may have seen, and it's okay if you don't know what they are right now. We have Elastic Beanstalk, which is the orchestration service offered by Amazon Web Service for deploying applications which orchestrates various AWS services. Now we are going to talk about what is SaaS. Now SaaS stands for a software as a service. To understand this, software as a service is the way companies deliver applications or software over the internet to the end user. Now with using a SaaS product, everything is already managed for you. You don't have to manage anything at all. The service provider manages everything from the application, the data, the runtime, the middleware, the operating system, the virtualization, servers, storage and networking. Now think about a company like Zoom that you may use all the time right now. The only thing you need to do is show up and connect with other people who show up and have a meeting on that software. Everything is managed in a way that if anything happens on the application or software, Zoom will already take care of it. Another one is we have Dropbox, which is a file storage service. That's all about SaaS. Next model is IaaS. What does IaaS stands for? Well, it is infrastructure as a service. Infrastructure as a service is a form of cloud computing that provides virtualized computing services over the internet to its users. So first, virtualization uses software to create an abstract layer over a computer hardware. And what this does is allow the elements like storage, processing power, etc. of the computer hardware to be divided and offered to its users as multiple computers. Now with infrastructure as a service, as the user you are responsible to manage the application, data, runtime, middleware and operating system, while the service provider manages the virtualization, servers, storage and networking. Now this leaves you a plenty of room to tailor services offered in this model to your business needs. Now here are some examples of the infrastructure as a service model that you should be familiar with. We have AWS, we have Google Cloud and we have Microsoft Azure. Yep, there are platforms that inherit the infrastructure as a service model and offer virtualization services and solutions just for you. And the last model is FaaS. What is FaaS? FaaS stands for Function as a Service. So what does that mean? Function as a Service is a cloud computing service that allows you to execute code in response to events. And it uses the serverless framework in which we will dive into later. Now think of a function in programming where the function takes data, processes it, responds or returns a result. This same thing is happening here. Now with the FaaS model, you will be responsible for managing only the application. Now everything else from the data to the internet is managed by the service provider. All you have to do is focus on the code. Now here are a few examples of services that use the FaaS model. We have AWS Lambda, which is a serverless service specifically for Amazon Web Services platform. And this uses the FaaS model. We have Google Cloud Function, which is a serverless FaaS service that is strictly for Google Cloud Platform. And then we have Azure Function, is a service strictly for the Microsoft Azure platform. Alright pedagogians, today we have discussed about cloud sharing and responsibilities, which also lead us to learn the types of cloud computing services. Welcome back to Cloud Pedagogy. In today's session, we will talk about what is server and serverless. First, we will see what is a server. Now, the technical definition of a server is a computer or a device that provides programmable service to another computer or its user. For non-technical person perspective, I would say server is anything that is ready to handle requests 24/7 as it's connected with the internet all the time. So now let's think about it is like this. Your computer is a program and you are its user. Let's say you wanted to connect to your Netflix account. You are actually connecting to your Netflix server that could be provisioned in the cloud with a specific CSP. That is cloud service provider like AWS, Azure or even Google Cloud. Now, by you connecting to the server, it allows you to have the experience dedicated to the server and what it's trying to provide for you. Now, as you learn more about servers, you will actually learn there are different types of servers, and here are a few. You have web servers, you have app servers, and you have the database servers. I'm not going to dig into the details, but all of them serve different purposes, but can work together to accomplish one goal. That is giving the experience to you, the user. We are going to answer the question next, what is serverless? Now, serverless architecture and the concept itself can get a little complex. But let's try to tackle it here in the most basic way possible. It is a cloud-native development model that allows developers to build and run applications without having to manage servers. It means the cloud service provider allocates machine resources on demand. Now remember, when we talked about function as a service and how that model allows you to execute code in response to events. Well, serverless is the framework that makes that happen. So you, the user, creates the code that will allocate resources in response to certain event dependencies within that code. So the user would never have to manage any resources at all. The provider will allocate everything you need in response to the activity within your code or a function. And that is the basics of serverless. Did you ever wonder what to choose for your application? Server or serverless? There is no clear winner. Serverless computing is more affordable, scalable and time efficient as you can focus on coding instead of server maintenance. Serverless is more affordable as most cloud providers offer the on-demand feature. You only pay for what you have actually used without spending money on unutilized products and functions. On the other side, server computing gives you more control and ensures unlimited access to your data even with no internet connection. However, if you do not have high costs of maintenance and suffer from an unstable internet connection, sticking with server computing might be wise. So, it's up to your choice what to choose depending on your use case. Well, I think that's all that I have to say for this session. Hello friends, welcome to Cloud Pedagogy. I knew you all were catching on and I knew you were learning. In this lesson, we will get to know who are the different cloud providers or cloud vendors. Cloud providers give you the flexibility to build, manage and deliver small and large scale web and mobile applications. With virtual server hosting, they provide you with diverse resources over the internet, such as big data analytics, IoT, compute, and more to streamline development. Cloud resources are typically offered with plug-and-play capabilities, allowing you to use only what you need when you need it. The CSP or cloud service providers market includes cloud providers of all shapes and sizes. The big three: Amazon Web Services, AWS, Amazon Azure, and Google Cloud are considered the established leaders. We have AWS, which is typically a feature and service heavy cloud service provider that has services tailored to your every need in the cloud. And they really try to roll out the red carpet with addressing solutions for companies. Then we have Microsoft Azure, and this is a cloud service provider that offers cloud computing services that you can use as a public cloud service, but more so they are tailored to your on-premises network as well, since a lot of data centers are Microsoft managed data centers already. And last we have Google Cloud, which is a major player in public cloud offerings, but they seem to be dedicated to development and big data, along with introducing a multi-cloud model that you can use their services along with any other major CSP. There are a few more public cloud providers like IBM Cloud, formerly SoftLayer, Oracle Cloud, Alibaba Cloud, Red Hat, Heroku, DigitalOcean, etc. Now we talked about the major cloud providers. We do have some major players that offer services in private cloud space as well. We have Red Hat, Dell, and VMware that offers a private cloud option for you to use outside of the public cloud. Now they are making their stamp as major corporations that are tailored to helping you offer a more secure environment for your cloud infrastructure. So keep those big players in mind as well. In this lesson, we have gotten to know some of the major players in public cloud, also the major players in private cloud as well. That's all for today's session. I'm sure we'll see each other again in the next lesson. Hello Cloud Pedagogians, welcome back. In previous sessions, we have completed the cloud computing fundamentals in a basic level so that you can start your journey of learning any cloud computing providers like AWS, Azure, GCP, etc. So choose your CSP wisely for your career and start learning. There were a few questions I was asked countless times from our students before choosing any CSP. So I hope this can provide a useful guide on this topic. The first thing, do I need to know the coding to start any cloud computing service? The answer is not at all. You can start using a public or private cloud computing service even if you are not a software developer. It doesn't require coding chops to get an account or launch resources in a cloud environment. So don't worry, you can go ahead and start your learnings. The next question, do I need to have some previous experience in the IT world? Again, I can say no. Cloud computing is a technology used in all industries globally. Understanding it will help everyone, not just technical people. Chances are you work at a company that is already using cloud infrastructure. It has different approaches and specific aspects for the different roles and responsibilities. But that's the beauty and opportunity within this field. It touches everyone. The next question is, how long does it take to learn? If you are entirely new to this, we recommend approximately 120 hours or 3 months to prepare. For experience, it's an ocean to cover all the services. The next question, how to do the labs? This is the biggest hurdle to implement your knowledge. There is no cost for signing up with any cloud service provider in the free trial mode. In free trials, there are only few resources that are free of cost. For others, you get charged for what you use. As a beginner, I was also not aware of these things and was charged by my cloud service provider. So be careful when you are creating resources in the cloud. The next question is, why did cloud service provider charge me for a free trial? When an account goes over the free tier limit, the standard cloud service provider service rates will be billed to your credit card. If you have not exceeded the limits of the free tier, you may have been charged for other cloud service provider services that are not covered under the free tier. Sometimes the exercises you may be doing in your cloud service provider's account may have an associated cost. if you intend to attempt those kinds of labs on your own, I would recommend to familiarize yourself with cloud service providers' charges. And do not forget to remove them after your exercises to avoid future buildings. In any case, if this is your first build and is innocent mistake, reach out to the cloud service provider support team. There is high possibility they may take out this charge for one time. So, good luck. I hope these guidelines clear some of your questions. Let me know if you have more. Until then, see you.